Armageddon is an easy difficulty Linux machine from HackTheBox. It runs a Drupal web application vulnerable to Drupalgeddon2, CVE 2018-7600, that allows the execution of arbitrary remote code against the target. Once obtained a shell, it is possible to extract MySQL credential from Drupal's configuration files and access local databases using mysql, where it is possible to find the hash for the local user's password. Once extracted the hash, it is possible to crack it and reuse the password to access the machine through SSH with local user privileges, discovering that the user was allowed to run snap with sudo capabilities. Finally, it is possible to craft or reuse a malicious snap package in order to execute custom code with high privileges and obtain a root shell. The initial port scan reveals there are only 2 services listening on external ports: OpenSSH over the port 22 and an Apache web server hosting a Drupal site over the port 80. Those services are also disclosing their fingerprint, allowing us to identify which distro the Linux machine is. Looking at the robot.txt file discovered by Nmap, it is possible to identify different files and directories exposed by the server, one of which is the changelog file that discloses the exact version of Drupal. Once obtained, it is possible to search for existing exploits targeting the exact version. Giving a rapid look on search exploit, it is possible to find that Drupal 7.56 is vulnerable to Drupalgeddon2, aka CVE 2018-7600, an unauthenticated remote code execution exploit that leverages a misconfiguration by poisoning the recovered password form and triggering it with the uploaded file via AJAX. The POC previously found on ExploitDB was written for Metasploit. However, a different one, written in Python, is also available on GitHub and is the one we are going to use. To test the vulnerability, we can first provide to the script a non-destructive payload, like ID or whoami. Since the command was executed without problem, we can then enumerate which shell is present on the machine, craft or copy an appropriate reverse shell payload, and then download and execute it. Once obtained a shell, we can try to upgrade it to a stable PTY using Python, however unsuccessfully. Okay, who cares, that's not a critical issue. We are still able to enumerate the target and search for possible hard-coded passwords. Because the server is hosting a Drupal site and CMS practically always uses databases, we can search online where Drupal saves its configuration file, and if we are able to extract some interesting stuff, like passwords, users, and databases. Cool, we obtained the credential for Drupal user. However, looking at the local users, we discovered that the only one is Bruce, the real admin. With the information extracted from the conf file, we can search inside MySQL for users' password or hashes. Unfortunately, we do not have a fully interactive shell, meaning that we cannot use the MySQL client in an interactive way. Luckily for us, however, MySQL provides a -e parameter that allows us to execute single or multiple queries from the command line. Okay, let's search and extract users' data. Oh damn, perfect. We found the Bruce the real admin's hash and now we can crack it using hashcat. Let's search the right format for Drupal hashes and then start to crack the password. We got it. We can now log in with Bruce the real admin's account. Let's check if he has some sudo capabilities. Apparently, he can execute snap with high privileges. Googling a bit, it is possible to discover that snap can be abused in order to install a malicious package and execute custom code. So let's create the malicious package following the instructions on GTFObins site. Okay, now upload it on the target and install it. What? Why does it not work? Maybe there could be some problem building the package from Kali. We could try downloading and creating an Ubuntu machine in order to craft the package there. However, we can adopt a different approach. When I was searching for snap privilege escalation vectors, I found an exploit called Dirty Stock, a privilege escalation exploit for snapd version prior to 2.36, which installs a malicious package, like the one we had created earlier, and injects an arbitrary sudo user within the local ones. Since our custom package did not work, we can try to use this POC to elevate our privileges and, in case it works, try to figure it out why the one we just created didn't. First, we create the package decoding the base64 payload in the same way as it is done in the exploit. Okay, now we have to install it and pray it works. Cool, it did. We can now switch to dirty sock user and then escalate to root using its sudo capabilities. There is still one thing I don't understand. What are the differences between this package and the one we have created at the very beginning? Well, let's compare the two files. The two packages are pretty the same. The few things that change between the two are the very first byte, the very last byte, and the architecture. Assuming the bytes are not the problem, let's try to change the specific architecture from all to AMD64 and verify if it works. Upload it on the server. Install it. It does. The problem was the architecture. Although I didn't fully understand why all doesn't work as a valid architecture, we successfully rooted the machine and found what the problem was with our payload, finally getting it to work. These were the skills that the machine wanted us to improve, and we managed to do it. So, congratulations and see you in the next video.